On with cool glasses.
Yes, I'll explain the cool glasses. So welcome to the Fall 2019 TWed Lightning Talks. So tonight's very special because we get to get the opportunity to hear 2 minutes from everybody in the Tetherless World Constellation who wants to speak about their projects, which mostly will be Tetherless World grad students, but hopefully some Tetherless World URPs, staff. If you want to spend a couple of minutes talking about what you're doing, you can do that as well. Mostly this is about the grad student sharing. We are recording. We're not streaming live. We haven't completely figured that out yet. We sort of have, but we're streaming to WebEx recording, and we will post the video of tonight's recording to our TWed YouTube site. Just a couple of logistics. We've got the names up here in the order that people registered. Thank you very much for registering. We've got a couple open spaces for people in the room who can be coerced into speaking who haven't signed up. Please, all you need to do is when we get to the end, if you want to come up there, put your name on there and then go to town. Our rules are really simple and painless. 2 minutes on pretty much anything you want to talk about, but it'll probably be about your research. No notes, no questions, lots of cheering after everybody speaks. Give them your appreciation the way you want to get appreciation from yours. And optionally, I think we ought to require it, talk with the Elton John glasses. You'll get extra bonus points if you talk with the Elton John glasses. So without further ado, it starts with Sabir.
They offer you some privacy.
And
there you go.
No email, no Git pulls, no Git pushes, just listening, paying attention. Okay? 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 There we go. The blessed sound of laptops closing. Hit it, Sabir.
All right.
Hello, everyone. I'm Sabir. So physicians or clinicians often find patients with unexpected outcomes, like maybe they're gaining weight or losing weight. Maybe there's some symptoms. They don't know why the patients are having these symptoms. Maybe some other unexpected outcomes or adverse events. So in order to explain these unexpected outcomes, what do physicians do? Well, they actually combine various forms of reasoning. So they do abductive reasoning, deductive reasoning, inductive reasoning, abstractions, all these sorts of things. So we want to create an AI system that's able to mimic how a physician diagnoses patients. And the way we're doing this is by creating a hybrid reasoner. So using semantic web technologies, we can already do deductive reasoning. So we're planning to build an abductive reasoner. So pretty much given a set of facts in the knowledge graphs, we want to explain how they got there to begin with.
Right? Short and sweet. Oh, and we cross out our names now. All right.
Let's see if I can do double glasses here.
Talk about peer pressure. There you go.
Right.
Do you actually need to see the audience?
No, this is better. I can't see the audience. Hello, everyone. My name is Matt Johnson. I'm going to talk about some work I did for the semantic bidding course over the semester. I was looking at ontology alignment, and I found kind of an interesting case that I just thought I'd talk about. So for one of the survey papers, an author went out and took a bunch of different ontology alignment algorithms and tested them against 3 data sets. And for one special interesting case, the algorithm did great in its own paper. It did great on the first data set, and it did horrible on the other 2. And it was kind of a shock because this was a well-known algorithm. And they went, and the authors actually kind of responded to this, and they said, well, it was a good experiment. You just didn't generate the correct hyperparameters. And that was the big problem here. This was a great algorithm. It does well, but there's a large number of hyperparameters to customize it to the data set. that this new third-party user of this algorithm just couldn't adapt to. And so this was kind of an interesting use case for me because I was thinking, well, yeah, we evaluate how long an algorithm runs, its accuracy in certain data sets, but not how hard is it for the next guy to use. And this kind of example highlighted that. And so with that new kind of perspective, I continued looking at, well, how hard are the other algorithms to actually implement and how many hyperparameters they have to work with? And yeah, so I guess just as a warning, a lesson learned, as you are developing algorithms in the future, keep an eye on that because somebody's got to use that someday. And if you want people to use it, you should try to make it as easy as possible because no one's going to know their algorithm as well as you know your algorithm. And I think that's all I got. Is that
All
2
right.
minutes?
Nobody knows your algorithm as well as you know your algorithm.
Yeah.
So
I'll put these here.
also let people know who your advisor is.
Oh, Deborah's my advisor.
Mine too. Hey, Matt.
Yeah.
Paper idea.
Yeah.
Hyperparameters considered harmful.
Thanks, man.
I'm trying to use notes.
Go ahead.
Yeah. Hi everyone, I'm Shruti. I am a first year PhD student working with Professor McGuinness. Today, uh, today, today, I will be talking about a project that we just started, Explainable Health Assistance. Um, um, essentially, what we essentially 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 the objective that we plan to achieve is to build a system to provide personalized, trustworthy, and also provenance aware health information to health information. This semester we conducted a literature review in the vast and also ever vast and also ever evolving literature of explainable AI. So essentially, what we did is to kind of categorize the papers into the categories of expert systems, cognitive assistance, semantic web, and also the machine learning domain. Um, additionally, uh, additionally, Additionally, we also recognize that different situations and context demand 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 different explanations. So for this task, we needed to look for the explanation types in in uh, in the fields of social sciences, philosophy, etc. as well. Besides the computer science domain. Um, overall, we found that our contribution could be a semantic understanding of the explanation space, accounting for the different entities, processes, and also the actors involved with explanations. Where we're at right now, actually, we are writing a book chapter on the foundations and directions of explainable knowledge enabled systems, and besides that, there will be also other developments next semester. So stay tuned for that. Thank you.
Thank you, Shruti. She didn't wear the cool glasses.
Yeah, I'm good with that. I want to see the audience, right?
Oh, no, you gotta wear the cool. Come on,
Yeah.
let's-
Okay.
Or you can take it.
There we go.
Yes. Okay.
You look good.
There we
Yeah,
go.
it's like double glasses.
That's right. They
Okay.
won't recognize you.
So I'm Jason. So I'm a fifth year PhD student working with Professor McGuinness. So today I'm gonna share some of my research during the summer in China and this fall semester. So what we are trying to do is the question answering task over knowledge graph. So for knowledge graph question answering, the semantic parsing-based methods aims at generates logical form representation for an input question. For example, if people ask what awards have been won by executive producer of the Timmy Time, which is a British a TV series animation for children. So in this kind of relatively complex question, so there are two triple patterns involved for the logical form of the input question. Uh, so to answer this question, we need to first generate the correct logical form for the parsing of the question. So what we are trying to do is to propose a neural network to generate such logical forms in triple pattern formats to help the task of question answering over the knowledge graph. And then we have conducted experiments on several uh, data sets which contains the question and the spiral query annotation pair for invariation, and then the result is quite competitive. So for future work, we want to further explore the combination of knowledge graph embedding and the KG QA tasks. We want to see whether the knowledge graph embedding can play a positive role in generating better and more accurate logical forms. Because currently the knowledge graph embedding methods are usually invariating using the triple classification and link prediction tasks, but we want to learn some better knowledge graph embedding specifically for the KGQA task. So this is my sharing for the day. Thank you.
All right. What the people don't realize is those glasses actually have monitors in them. There we go.
Not sure which one looks worse. But
What, do you want the worst one or the better one?
yes.
That one definitely looks cooler.
But this one looks cooler?
Yeah.
Okay. It also makes it harder to see. So, my name is Peter. I am a master's student under Dr. McGinnis. And in her class this semester, I did some work with a semantic web-based system for crowdsourcing the detection of fake news. So fake news is a very well-known and widespread problem, especially in today's political climate. And there have been some attempts already to make technological systems to help alleviate this problem. However, all of them either use machine learning, which often looks more at surface level aspects of the text and does not actually check its factual content, as well as machine learning can be tricked easily. Like a lot of people here I know went to that talk a few months ago about how to trick machine learning, or else they require expert users of the system to be fact checking, which creates a bottleneck. And neither of these options has any accountability for the system. So what I am proposing instead is this system where ordinary non-expert users can use this browser extension
to publish nanopublications about the content of articles they read, and they can say, this is true, this is false, this is true because this other source agrees with it, this is false because this other source disagrees with it. And they can also say nanopublications about what other users of the system are trustworthy, which will create this trust network, which will allow the system to show users explanations why an article they're reading is true or false, and give them like some provenance information of where the system got that recommendation, tailored to the user's existing trusts.
Like slash dot. Why is in. Go for it.
Yeah, of course. That's where I stand there. Whoa.
Ooh.
That's a little much. Okay. So I am Minor Gordon. I am a director of research under Dr. McGinnis, and I've been working on a project in my own time to create an ontology to describe collaboration networks. So these are what they sound like, networks of collaborators. The classic case is in scientific domains, people who publish papers together or who are in grants together. There's also artistic collaboration. I'm particularly interested in one domain, which is collaboration between nonprofits. So last year I worked for a technology consulting company that only worked with social impact nonprofits, and that's actually a really big problem. Nonprofits are competitive within a community. They're competing for grants and so on. And the funders don't often know what is actually happening in the community. So the idea was to create a system of metadata for describing what actually exists in terms of resources, people, services, data sharing systems, different sectors that are being served in the nonprofit community. So I'm using that to kind of address that problem. There's no money in that, so I'm doing it on my own time. There was no money in it then either, so it was always kind of a passion project. I'm also creating a web application to visualize those collaboration networks. I'm particularly interested in the sort of historical science collaboration networks. And I'm using the web application and all of the tools to pilot a bunch of things then that I do here, software stacks, using Scala, Sangria, GraphQL, triple stores, things like that, that I do, that I then take to work. So create a domain-specific language. I originally did that last year for building ontologies. So using that as a way to reinvigorate my work as well. Thank you.
Convention on the campfire, right? Obviously.
Everything ends.
Double glasses things. Okay, so hi, I'm Sola. I'm a new PhD student with Professor McGinnis as my advisor. And so as much as I love going out, getting pizza like we're having today, if you want to be eating healthy, generally what you want to be doing is cooking for yourself. Now, when you're cooking for yourself, you're typically kind of going to be going around a few recipes that you know you like, but maybe you need to be switching up those recipes a little bit once in a while. Maybe you don't have a particular ingredient this week. Maybe you're going to be cooking for a friend who has a certain food allergy. Maybe your doctor recently told you, hey, you need to cut down on the carbs that you're eating. So in order to do these kinds of things, it might be helpful to have some sort of system that can generate potential substitutes for individual ingredients within recipes, maybe even finding other recipes that are pretty similar to a recipe that you know you already like. So the project that I've been working on with the HEALS project is to be using the food KG, which is a food knowledge graph that another student made that includes a bunch of recipes, the ingredients that are used in those recipes, as well as links to nutritional information and like the food class hierarchy of those ingredients. And I'm trying to find substitutes for ingredients based on the context that it's used in. So maybe you would want to be substituting potatoes for cauliflower if it's like a mashed potato, but if a potato is being used in a stew, maybe you're finding a different kind of substitute for it. And so, yeah, we're trying to combine this kind of semantic technology and applying it to substitutability and similarity in the domain of foods and recipes. Got it? Thank you.
All right, let's see if this
I think it's
fits.
just like it's becoming the thing to do now.
It's not fitting very well, but
It's okay. It's cool.
thank you. Hi, I'm Owen. I'm working with the DSA project under Professor McGinnis. I'm an undergraduate researcher here. I'm going to be talking about, I guess, what I've been working on for the past month and hopefully working on for the next semester. I've been working on designing a domain-specific language for describing the policies that we use in the dynamic spectrum access project. Basically, we'd be describing a language that kind of abstracts away from the a bit like harder to type RDF that we use to describe it. So instead of needing to like put a bunch of RDF types, DSIT policies, we just describe it using like a single keyword such as policy. And basically, this would make it a lot easier for spectrum managers to actually develop the policies, add on to them, edit them, and so on. If you're dealing with like a text-based interface. Basically, we'd be applying this in something known as a language server. This is something that Microsoft developed as a way to basically perform like a bunch of syntax checking that doesn't depend on like an editor. So you don't need to write an entire stack just for like one editor to work with. And it would allow for users to be able to search up for previous URIs that have been defined, so that can perform like a lot of auto completions. I guess syntax completions and checking, all within like any editor. You just need to write a client for. And so yeah, that's what I've been working on.
And let's hear it for URP getting up to
Don't put on the glasses.
There you go.
Then you won't belong.
Hi, everybody. My name is Ethan Rambacher. I'm a co-term student working with Professor McGinnis. And I'll be talking about my master's project from this past semester, which is implementing a triple store that is backed by Elasticsearch. Elasticsearch is a very scalable distributed database, a document database. And basically, we implemented an Elasticsearch backend with the Jaina RDF API, which is used by some of the projects here. So hopefully this project, if performing, could actually be used in some of these other projects. And we benchmarked it, evaluated it against two other databases from Apache Jaina called TDB2. We used an in-memory and a persistent TDB2 databases, benchmarked that against the Elasticsearch backend, and found that the Elasticsearch backend is not quite as performant as the other two backends. And I should mention, we used the Berlin Sparkle benchmarks, which is a set of 12 queries that run against the Sparkle endpoint. And so we found that basically these queries performed poorer on the Elasticsearch backend than on the TDB2. In the future, ideally, this would be benchmarked against a few other options like BlazeGraph or Neptune, and also hopefully optimize a little bit further, as we haven't really optimized quite like reached the optimization limits yet. And that's all I have. Thanks.
All right. Let's hear it for co-terms.
Let's sit fine with these on. All right. Hello, everybody. My name is Kara Reedy, and I'm a fifth-year student working with Jim Hendler. If you've been around for a while, you've probably heard this a few times, but I work with an artificial life simulation that I've developed in Python. The simulation consists of an environment with various objects and agents that inhabit this environment and can interact with those objects. The goal of the simulation is for the population to evolve over time to learn to eat food and not rocks or each other, and to hopefully be fruitful and multiply and exist for many, many generations. Sometimes they die out after like 1,000 time steps, and I have to rerun it 50 times, but generally speaking, they're doing better than they used to, which is good. So these agents' decisions are made by their individual neural networks, and these neural networks are created by their genetics. Usually in something like a genetic algorithm, we use haploid genetics, which have one copy of the genetic material, but these agents are diploid, meaning that they have two copies of the genetic material. Not only does this work better for the specific simulation that I'm working in, it also opens up some more possibilities for future experiments. So one thing that I've been intending to do for a long time with the simulation is involving more aspects of social behavior between the agents. And so recently I've been looking at kinship discrimination, or the ability to differentiate between family and non-family and to treat them differently. So in my current experiments, I've introduced genetic disorders into the population using this diploid genetic system, and I'm looking at how different kinds and prevalence rates of genetic disorders affect the population's ability to evolve inbreeding avoidance, while hopefully still mating with non-family members. And if I have time before or after I hopefully get out of here, I would also like to look at how migration between different populations could also affect this rate of kinship discrimination.
Right. Most grad students hope that their work gets carried on, but somebody's going to have to take care of hers.
Do I have to?
Yes, you do.
So,
Well, not necessarily.
are these Matthews? Did you find them there?
Yeah.
Yeah, so, okay, fun story. We had high school kids this summer.
There's a code in there too.
Yeah, so this was Matthews. Yeah. Funniest person you'll ever meet.
Actually, look more natural.
Yeah.
They look amazing on you.
Yeah, really.
Thank you. Okay, cool. Hi, I'm Shweta. I'm Peter's student, Dr. Fox's student. Today I'm going to talk about emergency response decision making. It's a project we started about a year ago. It was basically trying to understand how emergency teams take the information they have by ad hoc situation they're presented with, and how they combine the knowledge of both these domains and tackle with the problems they're presented with. We started out thinking that it would be as easy as A plus B equals C, but it wasn't. We realized there's no path to a right answer when it comes to these emergency situations. So we scrapped the first set of models which we had, and it was not an easy breadth search first kind of a thing. So now we're moving on to design and improvisation, where it's like convergence of planning and execution. So now we're trying to understand what goes into the planning and the execution phases when it's such a time bound situation that you're presented with. And the simulation was ran in two forms, where you're actually interacting with the simulation as well as having a group discussion parallelly. So we have this huge data set that we're working with and trying to find the nuances in it and making sure that we get it right. So hopefully by next semester we'll be able to present some solid results, hopefully. Yeah. Thank you. That's fun.
Yeah.
If you don't want them, I'll take them.
Hello, I'm Sam. I'm a brand new software engineer with the Tetherless World. I started about roughly 3 weeks ago. I haven't really done any research here, so I'm just kind of introducing myself. I was a student here at RPI for my undergrad. I went to work for the state government for a couple of years. And I work for the state legislature, building open APIs that provide legislative data for people to make their own apps with. I thus far here at the Tetherless World, I've been working
on the DSA projects, working on some end-to-end testing, using this tool that I'm learning now called Cypress. And yeah, I've been really diving into the semantic web, learning about all these technologies, and thus far I'm really excited to be learning all this stuff, and really looking forward to working with all of you.
All right. Here's to new software engineers.
Yeah. We need those.
You are thing number 2.
Thing number 2.
Yeah, thing number 2.
Hi, everybody. I'm Chris. I'm a URP working under the DSA project. For this semester, I worked on creating a request builder to basically allow LGS internal users to test their own simulated radio requests against our topology. And so basically, the request builder allows the user to vary between just like a number of parameters: location, transmit power, frequency, radio type, and whatever, and be able to determine whether or not that particular radio request is permitted or not. So you can get like a permit with obligations, or a permit with reasons as to why a permission doesn't go through. And next semester I'll be working on a different project with temporal and spatial ontologies.
All right. So, you're still pretty good in classes.
Whoa.
All right.
Put these on. We'll go out with a bang. There we go.
There may be more people.
That's true. Well, we don't know. We'll see.
Yeah, really.
I've been up for about like 30 hours, so really bear with me here.
It's the best time to do it.
Yeah, right. Maybe I'll be a little, my nerves will be down. So I'm Nick Carey. I'm a senior here, physics student working with Dr. Fox for my senior thesis. And my senior thesis mostly focuses on trying to build, actually, and I'm really doing this so I can talk to you after. So it really trying to help understand model collaborative networks, specifically pertaining to in the educational space. So when you're working with a variety of different types of students, disseminating effective information, actually getting them to communicate and work together, and then also with subjecting them to experiences is very challenging, right? Yeah, exactly. As we probably all know from being TAs or professors or whatever. But when you're dealing, especially in places like the place I'm looking at right now is in Ghana, you have a really wide distribution of education levels and what people are trying to do, or like understanding their understanding and perception. And so at the same time, what I'm trying to explore is how we can build a type of collaborative network that can help individuals process and receive a firm understanding of how to complete projects, and then be able to effectively work together to address complex challenges within their communities. So my research has mostly spent this semester been trying to understand just, I come from physics, so my understanding of network science has been limited. So I've been trying to understand more about network science and kind of understanding some of the principles. And now next semester, I have been planning to go to Ghana in March to do if I get the money to do it, so we'll see, to actually do a more ethnographic approach to trying to understand and collect qualitative and quantitative information to better develop this network. So that's me. Thank you very much.
All the great network science came out of physics in the late 90s.
Yeah, it's really cool stuff.
Yeah.
Better than physics.
Now what?
All right. So people are dying in the United States at higher rates than in the rest of the developing world. We got to do something about it. To quote Kristen Bennett. So a group of undergraduate students have been working with us since very late in the spring 2019 term in developing an app called Mortality Minder, which is an entry in the Health and Human Services Agency for Healthcare Research and Quality Social Determinants of Health Visualization Challenge. And this is an app So in midsummer, we won the first round. We won $10,000 for being one of 12 teams. The other teams being people like Mathematica and the University of Minnesota School of Health and things like that, and little old RPI, little old group of grads or undergraduates. And we're submitting for the final on Friday, which is why I'm a little bit wired right now. And this app is it lets users, policymakers, providers, payers explore the regional disparities. I'm sorry, is that a word?
Disparities.
Disparities. What disparities? Let's crowdsource this talk. Starting at the national level, looking at both the changes in mortality rate at a county level across the nation, and then at individual state levels, and clustering those into high, medium, low risk groups based on their mortalities, understanding the trends, but most importantly, understanding determinants, social determinants, which are gathered from an aggregate site called County Health Rankings, which aggregates from 20-some sources. And it allows us to understand the protective and harmful social factors and visualize these trends and explore and dive into it. It also allows the users to get definitions of these different terms. And it really is it's designed completely on R, as one would expect. It's done as a sort of a multi-page web app using the R Shiny framework. It uses just some JavaScript presentational front ends such as full page, so it's got all the CSS good stuff in it. But it's very cool, and it's mostly done in real time. So we're seeing these correlations being calculated in real time and being presented and being interactive. We've had to go through all the stress inducers, like how does it work on a humongous display? How does it work on a tiny display? How does it work on Chrome? How does it work in Firefox? All these different things. And it's actually available right now at mortalityminder.idea.rpi.edu. Although it might change in 10 minutes when I do another merge. I'm the merge master for the whole project. That's why my hair is white. I started off with dark hair. So anyways, it's been a real fun project. It started off this summer with the usual students that we bring into the Data Insight program, math students, biology students, students who've been through the Intro to Data Math program, some of our past students from things like Health Analytics Data Lab, Health Analytics Research Lab. But this fall, we tried something different. We did an all-out call for students. We put posters up all over saying, you want to code, you want to do cool stuff, you want to change the world, come join us. So we got a bunch of CS people, had no R experience. And we decreed it's going to be done in R, it's going to be done this way. But it was a very good learning experience because number one, and thanks to a couple of people in this room who coached us, at least three people in this room, we had to put everything under tight source code management using GitHub, pull request a minute, merge every hour. We had to accept in some other viewpoints, how best to design these interfaces, maybe using some JavaScript techniques here and there to be able to adjust things. But also how we could apply with a lot of confidence sort of this pedagogy that we've been teaching for several years in the various data analytics courses. So it's been very cool. We're very excited to be actually completing something that we're very proud of. We'll see how it goes. If we win, we get $50,000 for first, or $30,000 for second, or whatever, $20,000 or something for third. So we'll hear sometime early in this, after the beginning of the year, where we stood. But anyways, it was a very fun project and a humongous learning experience for the Data Insight program. That's it.
Anybody else? All right. And to you.
All right. We had
3 talks already about the essay, so I'm going to talk about the essay itself. So the essay stands for Dynamic Spectrum Access, and behind this project, we have the motivation of the U.S. government sold chunks of spectrum to the industry, like AT&T, Verizon, and the other wireless companies, but they still want to use chunks of this spectrum for their own, mostly for military operation, but for the use as well. So what they did, they created some set of policies to regulate chunks of spectrum based on some attributes like what device are you using, what frequency range you're going to transmit, what you're going to do with this frequency for how long. So those documents exist. So in this project, we are creating a AI system that is able to represent machine-readable versions of those policies that are in natural language. But not only that, we're also providing a way for supporting the role of the spectrum manager, which is the person who's like allows or deny transmission, by presenting him with explanation of why a transmission got allowed or denied, so they can understand and they can proceed with the proper adjustments to be able to proceed with their specific operations and specific needs. So right now we have a working system. We have in this project, we have meetings every 6 months where we need to show what we have accomplished, right? And I think we do good. Huh?
I think we do good.
Yeah.
Yeah, I think we do good. Hooray for working system.
Yes.
But he looks just plain scary. Kind of look like my cousin Vinny.
So I said I didn't have anything, but of course that changes always.
Yeah, that's right.
Okay, so this is really, yeah, okay. It's like faded. It's very strange.
I know, don't try to figure him out.
Okay, so I have, this isn't what I'm working on, but it's a question. And I think it's a question that we might all want to think about, but it's also maybe a question that we can think about as a research project. And the question is, what's so difficult about RDF? Right? I mean, we all have we've all gone through the process of learning RDF to some degree. Sometimes it's easy, sometimes it's hard. Sometimes it fits like really naturally in our brains. Like I took to it really quickly. Although the first time I heard about it, I was like, well, why do I have to use URIs for everything? That's really awkward. But then once I realized why, it made sense and I went with it. So I'm wondering, is there some sort of cognitive impedance to thinking in terms of RDF, thinking in terms of ontologies, that maybe there's something there that we can either fix or address in terms of education. But clearly there's something there. And clearly we don't know what it is because everyone has a different opinion about what the problem is. That sounds like a usability study that could occur. It sounds like a entire cognitive science project of some sort that could maybe help us understand a bit more about what the heck is going on in people's brains and why it doesn't line up with how Sir Tim's brain works. I don't know. But yeah, there's something there. And I don't know if it's a full research project or if it's just people complaining, but I think it's something anyway.
I could have done that more polite. Here's the rethinking RDF. Not really. I think Sir Tim just thinks 3 times faster.
Yeah, and then he speaks 5 times faster.
Exactly. Yeah.
All right, you gotta try these. Oh yeah, interesting.
You look pretty good. I know. Don't try to figure them out.
Okay, so a couple things that I've done that are interesting over the last few months. One is going to advise a bunch of funders about what kind of investments the United States should make with respect to artificial intelligence and the next generation of wireless, which was pretty cool. And actually, one of the things that we heard at this workshop was a competition run by DARPA to do dynamic allocation. And interestingly enough, I think there were about 15 competitors. And they did 2 big rounds of the competition, and each time the winners were hybrid systems. So there were machine learning only approaches, there were rule-based only approaches, and there were hybrid systems, and each time the systems that won were hybrid approaches. So we tried to give some advice to funders. Another thing that I did that was, and there's going to be one theme across all 3. Another thing that I did was go to the press club in DC to talk to a bunch of foundations and a bunch of high-level government people and high-level researchers, including the chief statistician for the United States. Yeah, cool title. Well, and actually this woman owns data.gov. So that's under her purview. So the workshop was called Rich Context. So what do we need to represent about the context of everything that we do, about the data, about the solutions, what kind of language should that be in? It was a bunch of social scientists, it was behavioral economists, it was statisticians, it was funders, and a theme. So the first theme was kind of hybrid and be careful about the data that you use and what was done to it. This one is be thoughtful about the context in which everything happens, in which the data is collected, in which it's used. And a third thing that I did just a couple of weeks ago was represent RPI and AI. So I was the only person on the panel who was had AI credentials, and the only person representing RPI in a panel on artificial intelligence and the future of the capital region, particularly with respect to cybersecurity, clean energy, and environment, and in global climate change. And actually, one of the things that came out there also, I made this point, but too, was that a diversity of opinions are incredibly important. Diverse teams are incredibly important. Data from all over the place is incredibly important. Context is incredibly important. And no particular perspective on artificial intelligence alone is going to solve everything. So it's interesting as you move through the academic world and into positions where your voice might be heard more, about how you can help advise people who are in a position to really make differences in the world, like setting policies and setting directions for research. And I appreciate your support in this, because none of us professors could do this without you, and none of us could do this research without a full team.
Right, that's a great way to end it. All right. Thank you, and good night.
Thanks for organizing, John.
That's called organizing?